Welcome to this video. So we'll be talking about XML. XML stands for Extensible Markup Language. So this is a markup language very much like HTML, like Markdown, that allows us to represent data in textual format, but mark up this data to provide some extra information about the data itself. Now, in contrast to HTML, which is a markup language designed for data presentation, like we want to mark up data for visual presentation. For instance, this text should be a head. This text should be a bullet point. XML doesn't mark up data for presentation. The tags used to mark up the data in XML do not have any meanings associated with it. They basically provide a way to organize the data itself. Meaning XML itself doesn't do anything. It's how we read the XML and process it that gives meaning to the data. Let's take a look at this example here. So in this example here, we have a small XML document representing a note. And what that document says is that a note itself, and you can see the opening tag and the closing tag, which has the corresponding tag, note with a slash. This is the content of the note. Now, a note itself has a couple of sub-elements. They are called children tags in the lingo of XML. So a note has a to, from, heading, and body. Now, each one of these is a tag, and the tag itself, very much like HTML, is encoded with the two triangular brackets, the name of the tag, and they're closed with the corresponding closing tag with the slash here. What's inside the tag can be more tags, or it can be text. Like in this example, we have text, which basically says that the note is to, the text of the to tag is Tav, from is Janie, heading is reminder, and the body don't forget me this weekend. Okay. So obviously when we read this one, it's pretty self-descriptive for us. We can figure out that this is a note from somebody to another person with a subject, a heading information, and a body information. Now again, this XML document doesn't do anything. It's how we process it that gives it meaning. So we can process it for the purpose of presentation. So we can format things based on the tags themselves. We can read it for the purpose of data processing to extract, for instance, the from multiple notes, or to extract the body of multiple notes, and so on and so forth, which is what we will be doing in Python soon enough. So again, the main differences between XML and HTML is that XML was designed to annotate data, so it focuses on what the data is, whereas HTML is designed for displaying data, so it describes how the data looks like. And the XML tags are not predefined like HTML tags are, which means you're free to define your own tags. You can write what tags you want, and they will be valid as long as the syntax is valid. Now, before we close, XML also has an extra so the XML document itself looks like a hierarchy. A tag can contain multiple children tags, and each child tag can contain multiple children tags, and so on and so forth. The tag itself may have an attribute. So we don't have an example here, but let's take a look at one file in the data folder called, let's take a look at books.xml, for instance, or let's take a look at movies.xml. Okay, for some reason it's not formatted properly by the browser. So what I'm going to do, I'm going to open it using a text editor. So let's go to the containing folder here, and let's look for movies or books, and I'm going to open it with a text editor to see what's inside it. All right, here we go. So this XML document represents a collection of movies. So it's data about a movie library. And what you can see here that we have the opening tag, which is collection. Many editors will parse the document and provide some nice ways to navigate it, such as highlighting the syntax and provide way to collapse the tag. So you can see that the parent tag, which is called the root tag, is collection. Inside collection, we have multiple movies. Each one starts with a tag called genre. Actually, multiple genres, not multiple movies, multiple genres. That's a tag. And you can see here that the genre tag for each has an attribute called category, right? Obviously, there is the content of the tag, which is now collapsed. We don't see it. But the attribute, the tag itself has an attribute called category, which is action in this case, and thriller in this case. Now, if I expand this tag, I can see that in the genre tag, there are multiple children tag called decades, and the decade has an attribute called years, so 1980s and 1990s. If I look at this tag, it has multiple subtags, and each subtag or a children tag is called a movie. Let's collapse these movies here. So I've got here 3 movies in the 80s, and each movie has multiple attributes, including favorite, title, favorite and title in this case. Obviously, the movie tag has something else here, so I can expand, and you can see it has multiple, subtags or children tags: format, year, rating, and description. Now, these tags have text here, all of them, and the format has an attribute. So to summarize, the structure of the XML document is that we have tags, and each tag has 3 things: optional attributes, optional text, and also optional children tags. Okay, so that's kind of broadly speaking the structure of the XML, an XML document. So when we move to Python, we will be looking at ways to process the XML document using a library called elementary. And elementary will allow us to manipulate the document in multiple ways. Alright, so let's start by importing pandas and the elementary class elementary from a library called XML E3, which is the one we will need. Now, elementary provides multiple ways to read XML, including reading from a file, while the function is called parse. So I'm parsing the file movies.xml, and that will give me access to the XML document here. So actually, let's just take a look at XML here. And this is an element tree, a tree, because it's a hierarchy. All right, so we can do many things. We can get the root of that, and it will tell me that the root of this document is an element called collection. And we can explore now the tag, the text, and the attributes. So the tag is collection, obviously. The text is actually a blank, a new line, which if you look here in collection, that's probably the extra line here was recognized as text. Now it's not a big deal, but there is text which is not empty, it's a new line here. Okay. The attributes are nothing because there are no attributes. Say for instance, for the sake of this presentation, I create an extra attribute called owner, and let's say the owner is me. Oops, I'm going to save now. Well, let me delete the extra space. I'm going to save, and let's reread the file one more time. The tag is collection. The text is, there's still like a new line, I'm not sure why. The attributes now have an extra attribute, which is the owner. Okay. Now what's inside collection? This is what the method getChildren returns to us. It basically returns a list of the other tags, the other elements in the document. So a root.getChildren is basically telling me that there are two genres tags in this XML document, right? That corresponds to these genres, action and thriller. For each one of them, I can process each one of them. I can print the tag and I can print the attributes. Obviously, the tag is genre, I know that, but it's telling me that the attribute is, action and thriller. And I can do that again. I can I can take each tag in one genre, let's say thriller, child, and print all its subtags. I'm calling them grandchildren in this case, which will give me 1970s and 1980s. So that's interesting, but it's basically provide a challenge when we are processing the XML document. Because to process the XML document, you need to traverse through the document tree. And depending on what you want to do, that may be kind of a cumbersome process to just sniff through the whole document to look for a certain tag. So to help us navigate through the XML document, there are different ways we can do that. If you're interested in just one tag, for instance, such as a movie tag, you can use the function iter for iterator, which will give you an iterator over certain tags. So for instance, I can do a root.itr movie, which will give me basically an iterator over the movie tags, and I can process the movie tags themselves. Let's take a look here. So if I do root.iter movie, that's basically the iterator. If I force convert it to a list, I'm gonna get a list of these movies, okay? So this will be the first movie in the document. And then I can do, that's the movie, I can do everything, attribute or whatever, right? That's basically the first movie in the document. This one is the last movie in the document. So I can do that, and this is one of the simplest cases. Like, I'm just interested in movies, so here we go. Give me all the movie tags, regardless of where they appear. Even if I create a movie outside a genre, let's see, category is education. And let's just create an empty elements here. If I save this, I mean, obviously, if I save this, I need to reload the whole thing. So I'm going to load this here. Now, when I do this, you can see that the last movie is the movie that I just created. And this is nice because this one movie doesn't exist within a genre or a decade, but it's still picked up when I look for movie as a tag. All right, now the other way to navigate through an XML document is by providing a pattern that tells elementary what you're looking for exactly. And this pattern is described in a language called XPATH. So you can think about XPath very much like when you're specifying a path to a resource on the internet or a path to a resource in your file system, file explorer, or finder on a Mac, right? There is a path to each file, right? That's the path to the file. For instance, movies, it's sitting on my hard drive, users, AnySaf, course code, the name of the course, data folder, movie.xml. That's the path to the file. So we can think about each tag also from a path perspective because we've got a tree here. So XPath is the language that allows us to describe the path of the elements we're interested in. Okay, so let's take a look at the first example here. If I do for each movie in root.findAll genre decade movie, well, what this gives me is basically a list of all of the tags that are exactly in this path, genre, decade, and movie. And notice that my movie here that I added manually doesn't show up here, and that's because it's not within genre decade. It's just a movie standing on its own. So what I'm saying here will give me all the movie tags that exist in a genre decade, uh, in a decade parent tag, in a genre parent tag. That's the basic kind of XPath expression, but XPath has many more bells and whistles that one can use. So for instance, you can provide here a subquery to look at a certain, all of the movies that have a certain um, value of a certain subtag. So remember here that each movie, if you look at a certain movie, let's take a look at the movie here. The movie has multiple children tag, including year, rating, and description. So let's say I'm interested in only in movies that have a certain rating. Well, I can do something like this. I can say, well, why don't you give me all the ratings tags? Because rating is a tag, and that will basically give me all the rating tags. They don't have any attribute. If I put text, I'm gonna get all the ratings here. Okay, so, well, I mean, I know that the first movie then is a PG, 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 PG-13, and so on and so forth. But I'm not interested in the rating. I'm interested in the movie that has a certain rating. So the way to do it is to tell XPath, well, that's the route to the movie, but I'm interested in a subset of all these movies that have a rating tag, and the value of this rating is R. And that will give me the two movies that have this rating. Notice that there is a slash here because rating itself is a subtag of movie. We can also do a query on the attribute. Let's say I want all the movies that have the favorite attribute being true. Well, it's a very similar syntax, but notice there is no slash here because favorite is an attribute. It's not a subtag. And there's the at uh, symbol here to indicate that I'm interested in querying an attribute. So that's the syntax. If I'm interested in movies that have a certain attribute having a certain value, such as favorite equals to true, then that's the way I do it. Favorite equals to true in two square brackets without the slash, and I get a subset of these movies, such as what I see here. And we can combine both. So I can tell it, well, why don't you give me all the movies which have a favorite being true and a rating tag, favorite attribute being true, and the rating tag being R, and that's the only movie that satisfies these two criteria. So XPath is a more powerful way to kind of navigate through the XML document. It provides us a way to provide a pattern, and this pattern will be matched, and all of the tags that satisfy that pattern will be given back to us for further processing. Now, before we close, this example illustrates that really in XML there are two ways to put data. You can put a data point as an attribute in a tag, or you can put it as a text in a tag or a text in a subtag in a tag. Favorite could have been a subtag rather than being an attribute. I could have said, well, favorite here is true, and favorite here rather than being an attribute, which is not wrong, right? Um, and this is one point that why many people criticize XML, that it's really confusing, people on giving too many options, because you can put things in attributes and you can put things in tags. Some guidelines exist on whether you want to put your data in a tag or an attribute. That said, if you are using XML to encode your own data, for the purpose of our discussions, we're not interested in creating XML files. We're interested in reading XML files. So the data provider will describe the structure of the data, and it will tell you whether a certain piece of information is an attribute or a tag. And given that, we can extract the attributes and or the tags. Now, the last topic of this discussion is I want to talk about XQuery. Now, very much like GraphQL that I mentioned really briefly at the end of the last video, we are not going to use XQuery beyond introducing it in this session. But I want to introduce it because it's a technology that exists, and it's a technology which is very useful if you are handling XML as the main document. So if you end up working in a project where your data provider is providing most documents, most data in XML formats, XQuery is a very valuable technology. As a prelude to that, I just want to mention that XML as a standard existed before JSON, and there is a large amount of effort in creating the XML standard. Now, XML did not get the adoption that its creators envision it will. So, granted, there are many data providers, many technologies that rely on XML, but we are seeing a shift nowadays toward JSON, especially in newer technologies and newer formats. That said, XML still has a large market share, especially when it comes to government, non-for-profit organizations, because XML has a standardization body, whereas JSON is more kind of like a de facto standard. It's like a group of people who created it and it became widespread. So if you end up working with organizations that use XML, the governments use XML extensively, you will end up needing to process XML. So XPATH is one way to process XML. XQuery is another technology that allows us to process XML. And you can think about XQuery as SQL for XML. It basically allows us to write queries very much like queries in SQL, but instead of querying against a relational database, it's querying against an XML document. So I'm going to illustrate this concept here, and again, we're not going to revisit it beyond its introduction, but it's important for you to note the existence of this technology. We need to install a package called Simple XQuery in Python. If it doesn't exist, you can uncomment this line and just hit enter to pip install Simple XQuery. I have it installed, so I will just import it. And let's say I have this XML document here. Rather than reading it from a file, I just dumped it in the notebook because it's a small example. It's a bookstore. The bookstore root tag has multiple children tags, each book tag, and each book has an attribute called category and multiple subtags: title, author, year, and price. Okay, title has an attribute called lang, and each one of these tags have text, right? So the first book, it's a book about cooking. The title in English language is Everyday Italian. The author is Giada De Laurentiis. Year 2005, price $30, maybe 30, and so on and so forth. Okay, so that's the XML document. Now, let's take a look at a very simple XQuery here. And you can see that this XQuery is basically probing to get all of the books with a certain price less than 30. This is actually an an XPath query. So we can do that in XPath. That's not an issue. Okay, so that will tell me that, let's print actually, because there is like a line feed character, so I'm just going to print it to see it. The book, well, there's only one book that has a price less than 30, is this book, Harry Potter, in the category children. So that's XPath, but XQuery allows us to do something more sophisticated. So we can say for each one of the books where price is more than 30, give me all of these book order by title and give me the titles. So that basically will give me only the title tags for those books that have a price greater than 30. So you can see that this as a syntax is very similar to SQL. It's not SQL, but the designers of XQuery were inspired by SQL. Once again, XQuery has many more bells and whistles. I'm just introducing the technology. It's very powerful if you end up interacting with XML documents extensively. So that ends this presentation of XML, and next time we will look at interacting with HTML and reading and parsing HTML documents.